Good day, students. In this video, we're going to discuss the rules of differentiation involving transcendental functions. Okay, so what are transcendental functions? So, functions that are not algebraic. Example, exponential, logarithmic, trigonometric, and inverse trigonometric functions. Aside from that, we're going to discuss today how to compute higher order derivatives of functions. So first, let's have a review. Why are derivatives important? So that we have a deeper understanding of derivatives. So why are derivatives important? So again, derivatives are important because derivatives are a fundamental concept of calculus and are used extensively in many areas of mathematics, science, engineering, and economics. So derivatives are important for several reasons. Some of the importance of derivatives involves rate of change. So derivatives allows us to measure how quickly a function is changing at a specific point. This is important in many real-world applications, such as determining the speed of an object, the rate of growth of a population, or the rate of change of a stock price. So those are some of the importance of derivatives. So in computing the derivative of a function, we apply rules. So the importance of the rules of differentiation are important because they provide us a systematic way to find the derivative of any function. So the rules of differentiation allows us to find the derivative of more complex function by breaking them down into simpler parts and applying basic differentiation rules. For example, the chain rule is a rule of differentiation that allows us to find the derivative of composite functions, which are functions that are made up of other functions. The product rule is another important rule that allows us to find the derivative of products of functions. Without the rules of differentiation, we will have to rely on more traditional way of finding derivatives, like using the definition of the derivative formula and sometimes by trial and error or other less systematic methods to find the derivative of functions. The rules of differentiation also allows us to make connections between the behavior of a function and its derivatives. In summary, the rules of differentiation are important because they provide us with powerful tool for understanding and analyzing functions and their behavior. So before we proceed to rule number 7 and number 8. So let's recap the rules that we have discussed so far. So rule number 1, okay, so the derivative of a constant is 0. Rule number 2, power rule. Then the constant multiple rule. So it is the combination of a constant and power rule. Number 4, the sum and difference rule. Okay, so getting the derivative of each term separated by addition and subtraction. Rule number 5, the product rule. Okay, so two functions are being multiplied so that you can get the derivative using product rule. And number 6, the quotient rule. So instead of getting the product, you are getting the quotient of the two functions that are being divided. Rule number 7 and number 8 we're going to discuss today, that is the transcendental functions. Okay, so let's proceed to rule number 7, the derivatives of trigonometric functions. So here are the 6 trigonometric functions and their corresponding derivatives. How to derive these equations or these derivatives the rules for the derivatives of trigonometric functions. Okay, so all these formulas came from the definition of the derivative formula. Okay, so that is the basic formula in finding the derivatives. So the derivative of sine x is equal to cosine x. So the derivative of cosine x is equal to negative sine x. The derivative of tangent x is equal to secant squared x. The derivative of cotangent x is equal to negative cosecant squared x. The derivative of secant x is equal to secant x times tangent x, the derivative of cosecant x is equal to negative cosecant x cotangent x. So let's have an example. So we have two examples here, two functions. So let's try to answer. What is the derivative of the function secant x plus 3 cosecant x? So in finding the derivative of trigonometric functions, we will just use the formulas that I have given. So for letter A, we will write f prime of x is equal to, what is the derivative of secant x? So the derivative of secant x is secant x tangent x. Okay, so we're done with the first term. Second term, 3 cosecant x. What is the derivative of cosecant? So this is constant multiple rule, right? We have a constant, so just let's bring out the constant. Then the derivative of cosecant x is negative cosecant x cotangent x. Okay, so negative cosecant x cotangent x. Okay, so we will simplify. So secant x tangent x, then 3 times negative cosecant x cotangent x is negative 3 cosecant x cotangent x. Okay, clear? Questions? So that is the derivative of secant x plus 3 cosecant x. Okay, next, letter B. If the function is x squared sine x minus 3x cosine x plus 5 sine x, then what is the derivative? So the derivative will be, so g prime of x. If you will notice this, the first term consists of two functions, x squared and sine x. Okay, so if you have two terms separated by multiplication, so we will use the product rule. So what is the product rule again? So the product rule states that, so y prime is equal to copy the first term derivative of the second term plus copy the second term derivative of the first term. Then simplify if you have, if you can still simplify the function. Okay, so let's have the first term. So copy, so x squared, then derivative of the second. So the derivative of sine x is cosine x. Okay, plus, because this is product rule, so we are still in the first term. Okay, so copy the second term, sine x, then derivative of the first term. So the derivative of the first term is 2x. Okay, now we are done with the first term. So we're done with this. So done. So let's proceed to this one. For the second term, let's bring out negative. Okay, so this is subtraction. Then I will group it as this group. Okay, so I have positive 3x cosine x. So that is my function. Okay, so copy the first. So 3x, then derivative of the second. Okay, so derivative of cosine x is negative sine x. Okay, plus copy the second cosine x, then derivative of the first, which is a positive 3x. So positive 3x. The derivative of a linear function is just the numerical coefficient of the variable, which is 3. Correct? Okay. So we are done with the second term. So let's proceed to the last term. 5 sine x. So 5 sine x is just 5. Then the derivative of sine x is cosine x. Okay, so let's simplify further. So x squared times cosine x is x squared cosine x. Then 2x times sine x is 2x sine x. So here we have a group multiplied to a negative outside. So negative sine x times 3x is negative 3x sine x times negative. So this this multiplied to this times this. So it becomes positive 3x sine x. Okay? Then then we will multiply 3 times cosine x times negative. So it will become 3 cosine x. Okay, so minus 3 cosine x. Correct? Then 5 cosine x. So let's combine like terms. So we have here 2x sine x and 3x sine x. And so let's write the final derivative. So g prime of x is equal to x squared cosine x. Then 2x plus 3x is 5x sine x. Then negative 3 cosine x plus 5 cosine x is plus 2 cosine x. So this will be the final or the simplified derivative. Okay, question. Yeah, so for a better presentation. Question. So that is my last example for trigonometric functions. So we will proceed to rule number 8. So the derivative of an exponential function. So for the exponential function, we will going to discuss only e raised to x. Okay, so the other exponential function is b raised to x, or it means the base is not the Euler's number. Okay, so what is the derivative of e raised to x? So the derivative of e raised to x is also e raised to x. Where did this formula came from, or this rule came from? From the definition of the derivative formula. Okay, so all rules for differentiation are came from the definition of the derivative formula, the basic formula for the derivatives. So letter A, first example, find the derivative of the function 3e raised to x. So this is constant multiple rule, and we know the derivative of e raised to x. So the derivative of e raised to x, so e f prime of x is equal to 3, then the derivative of e raised to x is e raised to x. So this is our final answer. So the derivative of 3e raised to x is 3e raised to x. Okay, so next, find the derivative. So g prime of x of negative 4x squared e raised to x plus 5x e raised to x minus 10 e raised to x. We will use the product rule for this function. So let's find the derivative. So again, the product rule states that the derivative is equal to u v prime plus v u prime. Okay, so copy the first term, copy the first function derivative of the second. Okay, plus copy the second derivative of the first, so negative 8x. Okay, so we're done with the first term. Okay, so the derivative of the second term, again, it is product rule because 5x times e raised to x. So copy the first derivative of the second plus so 5x times the derivative of e raised to x is e raised to x. Then plus second term e raised to x, derivative of 5x is just 5. Okay, minus 10 e raised to x. Okay, so let's simplify and combine like terms. So negative 4 e raised to x, x squared. So this is minus 8 e raised to x, x plus 5 e raised to x, x plus 5 e raised to x minus 10 e raised to x. So combining like terms, negative 4 e raised to x, x squared, then this 3, right? Negative 8 e raised to x, then plus 5 e raised to x is negative 3 e raised to x, negative 3 e raised to x. So let me write negative 3 e raised to x, right? Then the last one, 5 e raised to x minus 10 e raised to x is negative 5 e raised to x. Clear? So that is our final answer. So what will be the formula for other transcendental functions? So let's have the first one. So if the base is not the Euler's number, so therefore the derivative of a raised to x is ln a, then a raised to x. Actually, if we'll go back to the formula, okay, so y is equal to e raised to x. So the derivative of e raised to x is e raised to x. Okay, so if you follow this rule, so it must have ln e, correct? But ln e is just 1. So the value of ln e is 1. So therefore, it will become e raised to x, simply e raised to x, simplified version. So this is the derivative of non-natural exponential function. Okay. So for logarithmic function, so what is the derivative of natural logarithmic function? X. So ln of x. So the derivative of ln of x is 1 over x. So how about non-natural logarithmic function? What is the derivative of log a? When you have log a of x, so the derivative of that is 1 over x, then ln of a. Okay? So this is for inverse sine. So arc sine x. So the derivative of arc sine x is 1 over square root of 1 minus x squared. Then the derivative of arctangent or inverse tangent x is 1 over 1 plus x squared. So why don't we have examples for these functions? So the examples for these functions are mostly under the chain rule. So that is our next rule. So the rule for all rules, the chain rule. Okay. So we will have that in our next topic. So for now, we don't have examples for this other transcendental functions. Okay. So let's proceed to higher order derivatives. So we will compute for the higher order derivatives of functions. So what is higher order derivatives of functions? So if we will consider a polynomial function, example x raised to 4 plus 3x cubed minus 4x plus 2, and the first derivative is 4x cubed plus 9x squared minus 4. But again, it is differentiable. Therefore, the function 4x cubed plus 9x squared minus 4 is still differentiable. So therefore, we may still differentiate the derivative to get the second derivative. So what is the second derivative? It's the derivative of the first. Okay, so f double prime of x is equal to the derivative of 4x cubed plus 9x squared minus 4, which is 12x squared plus 18x. Okay, so this is again another differentiable function. We call f double prime and its subsequent derivatives the higher order derivatives of f, like f prime, which we interpret as the slope of the tangent line. So the function f double prime will have an interpretation of the graph of f. This will be a lesson in college. It also has an important interpretation in physics if f denotes the displacement of a particle. For now, this lesson will reinforce our skills in differentiating functions. So we will just practice. Okay, so the application of this higher order derivatives will be tackled in your subjects in college and in your subject in physics in your grade 12. For now, we will just hone our skills. We will practice finding the higher order derivatives of functions. Okay, so let's have the first example. Find the fourth derivative of the function x raised to 5 minus 3x raised to 4 plus 2x cubed minus x squared plus 4x minus 10. Before we have the fourth derivative, we must have the first, second, and third derivatives before we can find the fourth. Let's start. Let's have the first derivative. It's just power rule. So bring down the power. Then the power minus 1. So 5x raised to 4. Then next term, bring down the power. 4 times 3. So negative 12. X 4 minus 1 is 3. X cubed. Then 2x cubed is plus 6x squared minus x squared is minus 2x. Then the last one, we have a linear 4x minus 10. So the slope of that, or the derivative of that, is 4. Okay, so we're done with the first derivative. So let's proceed to the second derivative. 5x raised to 4 is, the derivative of that is 20x cubed. The derivative of negative 12x cubed is 36x squared. The derivative of 6x squared is 12x. And the derivative of negative 2x plus 4 is just negative 2. Let's proceed to the third derivative. Okay, so 20 times 3 is 60, right? 60x squared minus 36 times 2 is 72. Then the derivative of 12x minus 2 is just 12. Okay, so now we're down to our fourth derivative. Okay, so 60 times 2 is 120. X minus 72. So this is our fourth derivative. So the fourth derivative of x raised to 5 minus 3x raised to 4 plus 2x cubed minus x squared plus 4x minus 10 is 120x minus 72. Okay, question. So let's proceed to our next. Find the first and second derivatives of the function defined by y is equal to 3x squared minus 4 times x squared minus 3x. So if you will notice, we have two functions, and we will practice the product rule. We are asked to find the first and second derivative. So let's have the first derivative. So copy, right? So again, y prime for product rule is u times v prime plus v times u prime. Okay, so 3x squared minus 4, then the derivative of the second function is 2x minus 3, plus copy the second function, so x squared minus 3x, then the derivative of the first is 6x. Yeah, just 6x. Okay, so let's simplify. We will FOIL this. So 2x times 3x squared is 6x cubed. Okay, then negative 4 times 2x is negative 8x. Then negative 3 times 3x squared is negative 9x squared. Then negative 3 times negative 4 is plus 12. Okay, so next, so plus this one, so 6x cubed, then this one negative, so minus 18x squared. Okay, so we are still at the first derivative. So let's simplify. 6x cubed, I have 6x cubed here, I have 6x cubed here, so 12 x cubed. So let's have squared. So negative 9x squared, then we have negative 18x squared, so we have negative 27, right? negative 27x squared. Next, we have the negative 8x, then plus 12. Okay? Okay, so let's have the second derivative. So the second derivative is the derivative of the first. So 12 times 3 is 36 x squared. Then 27 times 2 is 1454 x. Then minus 8. So that is the second derivative of the function. Okay, so let's erase everything and let's see the presentation. Okay, so if you have any questions, clarifications, so kindly fill out the Google evaluation form. Okay, so that's all for today. God bless.